Yeah, it's been a long time coming, and I think the last time we talked, I've always been hopeful, but it seemed like it was getting closer. So with 3.12, we were able to land per interpreter GIL, which kind of was the last piece, the foundational part I wanted to do. A lot of cleanup, a lot of work that had to get done, but that last piece got in for 3.12.
Excellent. So good. And maybe let's just do a quick check-in with you all. It's been a while. Anthony, start with you, I guess. Quick intro for people who don't know you, although I don't know how that's possible, and then just what you've been up to.
Yeah, I'm Anthony Shaw. I work at Microsoft to lead the Python advocacy team, and I do lots of Python stuff, open source, testing things, building tools, blogging, building projects, sharing
you have
things.
A book, something about the inside
of Python?
I
have a book as well.
Yeah,
I forget about that. There's a book called CPython Internals, which is a book all about the Python compiler and how it works.
You suppressed the memory of writing it, like it was too traumatic. It's down there deep.
Yeah, I keep forgetting. That book was for 3.9, and people keep asking me if I'm going to update it for 3.13 maybe, because things keep changing.
Yeah.
Things are definitely changing at a more rapid pace than they were a few years ago as well, so that maybe makes it more challenging. Recently I've been doing some more research as well. So I just finished my master's a few months ago, and I started my PhD, and I'm looking at parallelism in Python as one of the topics. So I've been quite involved in subinterpreters and the free threading project and some other stuff as well.
Awesome. Congratulations on the master's degree. That's really great.
Thanks.
And didn't realize you were going further. So cool. Yeah. Eric.
Yeah, Eric Snow. So I've been working on Python as a core developer for over 10 years now, but I've been kind of participating for even longer than that, and it's been good. I've worked on a variety of things, a lot of stuff down in the core runtime of CPython, and I've been working on this, trying to find a solution for multi-core Python since 2014.
Yeah.
So I've been ever so slowly working towards kind of that goal, and we made it with 3.12, and there's more work to do, but that's kind of a lot of the stuff that I've been working on. I'm at Microsoft, but don't work with Anthony a whole lot. I work on the Python performance team with Guido and Brant Booger and Mark Shannon, Eric Cottrell, and we're just working generally to make Python faster. So my part of that has involved subinterpreters. But awesome. Interestingly enough, it's only really this year that I've been able to work on all this subinterpreter stuff full time. Before that, I was working mostly on other stuff. So it's kind of this year's been a good year for me.
Yeah, I would say that must be really exciting to get the, like, you know what, why don't you just do that? That'd be awesome for us.
Yeah, it's been awesome.
Well, maybe since you're on the team, let's a quick check-in on Faster CPython. It's made a mega difference over the last couple of releases.
Yeah, it's kind of interesting. Mark Shannon definitely has a vision. He's developed a plan as of like years ago, but we finally were able to get him, put him in a position where he could do something about it, and we've all been kind of pitching in. A lot of it has to do with just applying some of the general ideas that are out there regarding dynamic languages and optimization.
Yeah. Things
have been applied to other things like HHVM or various of the JavaScript runtimes. And so a lot of specialization, adaptive specialization, a few other techniques, but right now, and a lot of that stuff we're able to get in for 3.11. In 3.12, there wasn't quite as much impactful stuff. We're kind of gearing up to effectively add a JIT into CPython, and that's required a lot of kind of behind the scenes work to get things in the right places.
Mm-hmm.
So we're somewhat targeting 3.13 for that. So right now, I think with where things are at, we're kind of break even performance wise, but there's a lot of stuff that we can do. A lot of optimization work that really hasn't even been done yet that'll take that performance improvement up pretty drastically. It's kind of hard to say where we're going to be, but for 3.13, it's looking pretty good for at least some performance improvement because of the jitting and optimization work.
That's exciting. Yeah, we have no real JIT at the moment, right?
Not in CPython.
Yeah. I mean, I know
Anthony
different things,
did his best.
I know. Well, that's actually super exciting because I feel like that could be another big boost potentially. You know, with the JIT, comes all sorts of things like inlining of small methods and optimization based on type information and
Yep, all that stuff. And one of the most exciting parts for me is that a lot of this work, not long after I joined the team, so what, 2.5 years ago, somewhere in there, pretty early on, we started reaching out to other projects that were interested in performance and performance of Python code. And we've worked pretty hard to collaborate with them. So like the team over at Meta, they have a lot of interest in making sure Python is very efficient. And so we've actually worked pretty closely with them, and they're able to take advantage of a lot of the work that we've done, which is great.
Yeah, there seems to be some synergy between the Cinder team and the Faster CPython team. So awesome. But let's focus on a part that is there, but not really utilized very much yet, which is the subinterpreters. So back on, when is this, 2019? Eric, I had you on and we talked about, can subinterpreters free us from Python's GIL? And then since then, this PEP has been accepted, but it's Anthony's fault that we're here. Because Anthony posted over on Mastodon, hey, here's a new blog post, me running Python parallel applications with subinterpreters. How about we use Flask and Fast API and subinterpreters and make that go fast? And that sounded more available in the Python level than I kind of realized the subinterpreter stuff was. So that's super exciting, both of you.
Yeah, it's been fun to play with it and try and build applications on it and stuff like that. And working with Eric probably over the last couple of months on things that we've discovered in that process. Especially with C extensions.
Yeah,
that's one. With C extensions, and I think that some of those challenges are going to be the same with free threading as well. So it's how C extensions have state, where they put it, whether that's thread safe. And as soon as you kind of open up the possibility of having multiple GILs in one process, then what challenges does that create?
Absolutely. Well, I guess maybe some nomenclature first. Not no GIL Python or subinterpreter Python. Free threaded. Is that what we're calling it? What's the name? How do we speak about this?
It's not quite settled, but I think a lot of people have taken to referring to it as free threaded.
Oh, I can go with that.
I mean,
that sounds pretty
people
good.
Still talk about no GIL, but it's free threaded is probably the best bet.
Are you describing what it does and why you care, or are you describing the implementation, right? Like the implementation is it has no GIL, so it can be free threaded, or it has subinterpreters, so it can be free threaded. But really what you want is the free threaded part. You don't care actually about the GIL too much, right?
Kind of. Well, it's interesting with subinterpreters. It really isn't necessarily a free threaded model. It's kind of free threaded only in the part at which you're like moving between interpreters. So
Right.
you only have to care about it when you're interacting between interpreters. The rest of the time, you don't have to worry about it. That where with the no-GIL is more kind of what we think of as free threading, where everything is
Right.
unsafe.
And for people who don't know, the no-GIL stuff is what's coming out of the Cinder team and from Sam Gross, and that was also approved, but with the biggest caveat I've ever seen on an approved PEP.
Yeah.
Like, we approve this, but we also reserve the right to completely undo it and not approve it anymore. But fair. And it's also a compiler flag that is an optional off by default situation. So should be interesting.
Yeah, we can maybe compare and contrast them a bit later as well.
Yeah, absolutely. Well, let's start with what is an interpreter? So then how do we get to subinterpreters? And then like what work did you have to do? I heard there was a few global variables that were being shared, Eric.
Yeah.
Maybe let's give people a quick rundown of like, what is this and how is it this new feature in 3.12 changing things?
Yeah, subinterpreters in a Python process, when you run Python, everything that happens, all the machinery that's running your Python code is running with a certain amount of global state. And historically, you can think of it as, across the whole process, you've got a bunch of global state. If you look at all the stuff like in the sys module, sys.dot modules or sys.dot whatever, all those things are shared across the whole runtime. So if you have different threads, for instance, running, they all share that stuff, even though you're going to have different code running in each thread. So all of that runtime state is everything that Python needs in order to run. But what's interesting is that the vast majority of it you can think of as the actual interpreter. And so that state, if we treat it as isolated and we're very careful about it, then we can have multiple of them. That means that when your Python code runs, that it can run with a different set of this global state, different modules imported, different things going on, different threads that are unrelated and really don't affect each other at all. And then with that in mind, you can take it one step farther and say, well, let's completely isolate those and like not even have them share a GIL, right? And then at that point, that's where the magic kind of happens. So that's kind of my first goal in this whole project was to get to that point, because once you get there, then it opens up a lot of possibilities when it comes to concurrency and parallelism.
Yeah, then Anthony can start running with his blog posts and showing off cool things. Yeah, absolutely. So one thing I don't know the answer to, but might be interesting, is Python has a memory management story in front of the operating system virtual memory that's assigned to the process with pools, arenas, blocks, those kinds of things. What's that look like with regard to subinterpreters? Does each subinterpreter have its own chunk or set of those for the memory it allocates, or is it still a shared one thing per process?
It's per interpreter. This is something that was very global, and like you pointed out earlier, this whole project was all about taking all sorts of global state that was actually stored in like C global variables all over the place, right? And pulling those in together into one place and moving those down from kind of the process global state down into each interpreter. So one of those things was all of the allocator state that we have for objects. And Python kind of has this idea of different levels of allocators. The object allocator is what's used heavily for Python objects, of course, but some other state as well. And the object allocator is the part that has all the arenas and everything, like you were saying. Yeah. So part of what I did before we could make the GIL per interpreter, we had to make the allocator state per interpreter.
Well, the reason I think that it's interesting in asking about it is one, because of the GIL, obviously, but the other one is it seems to me like these subinterpreters could be used for a little bit of stability or isolation. I want to run some kind of code, and when that line exits, I want the memory freed. I want modules unloaded. I want it to go back to the way it was.
Yeah.
You know what I mean?
Yeah.
Whereas normally in Python, even if the memory becomes free, right, it's still got some of that, like, well, we allocated the stuff, now we're holding it to refill it, and then you don't unimport modules, and the modules can be pretty intense, actually, if they start allocating a bunch of stuff themselves and so on. What do you guys think about this as an idea, or as an aspect of it?
Yeah, there's one example I've been coming across recently, and this is a pattern. I think it's a bit of an anti-pattern actually, but some Python packages they store like some state information in the module level. So an example is a SDK that I've been working with, which has just been rewritten to stop it from doing this. But you would put the API key of the SDK, you would import it. So you'd import X and then do like X dot API key equals. So it basically stores the API key in the module object, which is fine if you've imported the module once and you're using it once. But what you see is that if you put that in a web application, it just assumes that everyone uses the same key. So, you can't import that module and then connect to it with different API keys, like you'd have different users or something.
Right. So you had some kind of multi-tenancy, right? Where like they would say, enter their ChatGPT OpenAI key, and then they could work on behalf of that, right? That potentially something like that, right?
Yeah, exactly. So that's kind of like an API example, but there are other examples where, let's say you're loading data or something, and it stores some temporary information somewhere in like a class attribute or even like a module attribute like that. Then if you've got one piece of code loading data and then in another thread in a web app or just in another thread generally, you're reading another piece of data and they're sharing state somehow, and you've got no isolation. Some of that is due to the way that people have written the Python code or the extension code has kind of been built around, we'll just put this information here, and they haven't really thought about the isolation. Sometimes it's because on the C level especially, that because the GIL was always there, they've never had to worry about it. So, you could just have a counter, for example, or there's an object which is a dictionary that is a cache of something. And you just put that as a static variable, and you just read and write from it. You've never had to worry about thread safety because the GIL was there to kind of protect you. You probably shouldn't have built it that way, but it didn't really matter because it worked.
Well, what about this, Anthony? What if we can write it on one line, it'll probably be safe, right? If we can fit it on just one line of Python code, it'll be okay.
Yeah.
Dictionary.add. What's wrong there? Dictionary.get. It's fine.
Yeah. So yeah, what we're saying within subinterpreters, I think what's the concept that people will need to kind of understand is where the isolation is, because there are different models for running parallel code, and at the moment we've got coroutines, which is asynchronous, so it can run concurrently. So that's if you do async and await, or if you use the old coroutine decorator. You've also got things like generators, which are kind of like a concurrent pattern. You've got threads that you can create. All of those live within the same interpreter and they share the same information. So you don't have to, if you create a thread, inside that thread, you can read a variable from outside of that thread, and it doesn't complain. You don't need to create a lock at the moment, although in some situations you probably should. And you don't need to re-import modules and stuff like that, which can be fine. And then at the other extreme, you've got multiprocessing, which is a module in the standard library that allows you to create extra Python processes, and then kind of gives you like an API to talk to them and share information between them. And that's kind of like the other extreme, which is you've got on it is the ultimate level of isolation. You've got a whole separate Python process, but instead of interacting with it via the command line, you've kind of got this nicer API where you can almost treat it like it's in the same process as the one you're running from.
Yeah, it's kind of
So you
magical,
can be
actually,
like,
that at all work. You get a return value from a process, for example, right?
yeah. But the thing is, if you peel back the covers a little bit, then like how it sends information to that other Python process involves a lot of pickles.
Yeah.
And it's not particularly efficient. And also a Python process has a lot of extra stuff that you maybe necessarily didn't even need. Like you get all this isolation from having it, but you have to import all the modules again. You have to create the arenas again, or the memory allocation. You have to do all the startup process again, which takes a lot of time. It's like at least
Parsing
200
the Python code
milliseconds.
again, right? At least the PYC. Yeah.
Yeah, exactly. So you basically created like a whole separate Python. And if you do that just to run a small chunk of code, then it's not probably the best model at all.
Yeah, you have a nice graph as well that shows like sort of the rate as you add more work and you need more parallelism. We'll get to that, I'm sure. One thing that struck me coming to Python from other languages like C, C++, C#, there's very little locks and events, threading, coordinating stuff in Python. And I think that there's probably a ton of Python code that actually is not actually thread safe, but people kind of get away with it because the context switching is so coarse grained, right? Like you say, well, the GIL's there, so you only run one instruction at a time, but like this temporary invalid state you enter to as part of like just your code running, like took money out of this account and then I'm going to put it into that account, right? Those are multiple Python lines and there's nothing saying they couldn't get interrupted between one to the other and then things are busted, right? I feel there's some concern about adding this concurrency, like, oh, we're having to worry about it. Like you probably should be worrying about it now. Not as much necessarily, but I feel like people are getting away with it because it's so rare, but it's not, it's a non-zero possibility. What do you guys think?
Yeah, I mean, those are real concerns. It's as there's been lots of discussion with the no-GIL work about really what matters, what people we need to care about, really what impact it's going to have. And I mean, it's probably going to have some impact on people with Python code, but it'll especially have impact on people that maintain extension modules.
Yeah.
But it really is all the pain that comes with free threading. That's what it introduces with, the benefits as well, of course. But what's interesting, I'd like to think of subinterpreters kind of provide the same facility, but they force you to be explicit about what gets shared, and they force you to do it in a thread safe way. So you can't do it without thread safety, and so it's not an issue. And it doesn't hurt that people really haven't used subinterpreters extensively up till now, whereas threads are kind of something that's been around for quite a while.
Yeah, it has been. It's subinterpreters have traditionally just been a thing you can do from C extensions or the C API, which really limits them from being used in just a standard, like I'm working on my web app, so let's just throw in a couple of subinterpreters,
Yeah.
But in 3.13, is that when we're looking at having a Python level API for creating, interacting with?
Yeah, I've been working on a PEP for that, PEP 554. I recently created a new PEP to replace that one, which is PEP 734. That's the one. So that's the one that I'm targeting for 3.13. And I don't know, it's pretty straightforward. Create interpreters and kind of look at them, and with an interpreter, run some code, pretty basic stuff. And then also, because subinterpreters aren't quite so useful if you can't cooperate between them, there's also a queue type that, you push stuff on and you pop stuff off, and just pretty basic.
So you could write something like await queue.pop or something like that. Excellent.
Yeah. So
yeah, this is really cool. And the other thing that I wanted to talk about here, looks like you already have it in the PEP, which is excellent. Somehow I missed that before, is that we have thread pool executors, we have multi-processing pool executors, and this would be an interpreter pool executor.
Mm-hmm.
What's the thinking there?
People are already familiar with using concurrent.futures. So if we can present the same API for subinterpreters, it makes it really easy, because you can set it up with multiprocessing or threads and switch it over to one of the other pool types without a lot of fuss.
Right. Basically, with a clever import statement, you're good to go, right? From whatever import, like multiprocessing pool executor as pool executor, or interpreter pool executor as pool executor, and then the rest of the code could stay potentially.
Yeah. What I expect
the communication, like it's gotta kind of be a basic situation.
Yep.
Right. Because there are assumptions.
Yep. Yeah, and it should work mostly the same way that you already use it with threads and multiprocessing. But we'll see. There's some limitations with subinterpreters currently that I'm sure we'll work on solving as we can. But so we'll see. It may not be quite as efficient as I'd like at first with the interpreter pool executor, because we'll probably end up doing some pickling stuff, kind of like multiprocessing does. Yeah. Although I expect it'll be a little more efficient.
I was gonna save this for later, but I think maybe it's worth talking about now. So first of all, Anthony, you wrote a lot about and have actually had some recent influence on what you can pass across, say, the starting code and then the running interpreter. That's kind of like the sub-interpreter doing extra work. Want to talk about like what data exchange there is?
Yeah. So when you're using any of these models, multiprocessing, sub-interpreters, or threading, I guess you've got three things to worry about. One is, how do you create it in the first place? So how do you create a process? How do you create an interpreter? How do you create a thread? The second thing is, how do you send data to it? Because normally the reason you've created them is because you need it to do some work. So you've got the code, which is, when you spawn it, when you create it, the code that you want it to run, but that code needs some sort of input, and that's probably going to be Python objects. It might be reading files, for example, or listening to a network socket. So it might be getting its input from somewhere else, but typically you need to give it parameters. Now, the way that works in multiprocessing is mostly reliant on pickle. So if you start a process and you give it some data, either as a parameter or you create a queue, and you send data down the queue or the pipe, for example, it pickles the data. So you can put a Python object in, it uses the pickle module, it converts that into a byte string, and then it basically converts the byte string on the other end back into objects. That's got its limitations because not everything can be pickled. And also some objects, especially if you've got an object which has got objects in it and it's deeply nested, or you've got a big complicated dictionary or something that's got all these strange types in it which can't necessarily be rehydrated from a byte string. An alternative, actually, I do want to point out, because for people who come across this issue quite a lot, there's another package called dill on PyPI. So if you think of pickle, think of dill. Dill is very similar to pickle. It has the same interface, but it can pickle slightly more exotic objects than pickle can. So often if you find that you've tried to pickle something, you try to share it with a process or a subinterpreter, and it comes back and says this can't be pickled. You can try dill and see if that works. So yeah, that's the typical way of doing it, is that you'd pickle an object, and then on the other end you would basically unpickle it back into another object. The downside of that is that it's pretty slow. It's equivalent, like if you use the JSON module in Python, it's kind of similar, I guess, to converting something into JSON and then converting it from JSON back into a dictionary on the other end. Like it's not a super efficient way of doing it. So subinterpreters have another mechanism, and I haven't read PEP 734 yet. So I don't know how much of this is in the new PEP, Eric, or if it's in the queue. But there's
much the same.
Okay, it's much the same. So there's another mechanism with subinterpreters, because they share the same process, whereas multiprocessing doesn't. They're separate processes. Because they share the same process, you can basically put some data in a memory space which can be read from a separate interpreter. Now you need to be, Python needs to be really careful. You don't need to worry too much about it, because that complexity is done for you. But there are certain types of objects that you can put in as parameters. You can send either as startup variables for your subinterpreter, or you can send via like a pipe, basically backwards and forwards between the interpreters. And these are essentially all the immutable types for Python, which is like string, Unicode strings, byte strings, bool, none, integer, float, and tuples. And you can do tuples of tuples as well.
And it seems like the tuple part had to something that you added recently, right? It says I implemented tuple sharing just last week.
Yeah, that's in now. I really wanted to use it, so I thought, well, instead of I kept complaining that it wasn't there, so I thought instead of complaining, I might as well talk to Eric and work out how to implement it.
Yeah, that's awesome. Hey,
but yeah, you can't share dictionaries. That's one.
Yeah, exactly. So one thing that I thought that might be awesome. Are you familiar with message spec? You guys seen message spec? It's like Pydantic in the sense that you create a class with types, but the parsing performance is quite a bit, like much faster. 80 times faster than Pydantic, 10 times faster than Marshuro and Seatters and so on. And faster still even than, say, JSON or UJSON. And so maybe it makes sense to use this, turn it into its serialization format's bytes, send the bytes over and then pull it back. I don't know. Might give you a nice
way. You can share byte strings. So you can stick something into Pickle, or you can use like message spec or something like that to serialize something into a byte string and then receive it on the other end and rehydrate it.
Or even Pydantic. Like Pydantic's awesome as well. It's just this is meant to be super fast with a little bit of less behavior, right?
Yeah, so this is a kind of a design thing I think people need to consider when they're like, great, I can run everything in parallel now. But you have to kind of unwind and think about how you've designed your application. Like, at which point do you fork off the work?
Yeah.
And how do you split the data? You can't just kind of go into it assuming, oh, we'll just have a pool of workers and we've kind of got this shared area of
right. I'll pass it a pointer to
everybody just
a million. Yeah, I'll pass it a pointer to a million entry list and it'll just run with it.
Yeah, because I mean, in any language, you're going to get issues if you do that. Even if you've got shared memory and it's easier to read and write to the different spaces, you're going to get issues with locking. And I think it's also important with free threading. If you read the spec or kind of follow what's happening with free threading, it's not like the GIL's disappeared. The GIL's been replaced with other locks.
Yeah.
So there are still going to be locks. You can't just have no locks. If you've got things running
threads, right? Like it moves some of the reference counting stuff into like, well, it's fast on the default thread, the same thread, but if it goes to another, it has to kick in another more thread safe case that potentially is slower and so on.
Yeah. So yeah, the really important thing with subinterpreters is that they have their own, have their own GIL. So each one has its own lock, so they can run fully in parallel, just as they could with multiprocessing. So I feel like a closer comparison with subinterpreters is multiprocessing.
Yeah, absolutely.
because they basically run fully in parallel. If you start 4 of them and you have 4 cores, each core is going to be busy doing work. You start them, you give them data, you can interact with them whilst they're running, and then when they're finished, they can close and they can be destroyed and cleaned up. So it's much closer to multiprocessing. But the big difference is that the overhead, both on the memory and CPU side of things, is much smaller. Separate processes with multiprocessing are pretty heavyweight. They're big workers. And then the other thing that's pretty significant is the time it takes to start one. So starting a process with multiprocessing takes quite a lot of time. And it's significantly, I think it's like 20 or 30 times faster to start a subinterpreter.
You have a bunch of graphs for it somewhere. There we go.
Yeah.
So I scrolled past it. There we go. It's not exactly the same, but kind of captures a lot of it there. So one thing that I think is exciting, Eric, is the interpreter pool, subinterpreter pool, because a lot of the difference between the threading and the subinterpreter performance is that startup of the new arenas and like importing the standard library, all that kind of stuff that still is going to happen. But once those things are loaded up in the process, they could be handed work easily, right? And so if you've got a pool of, like say that you have 10 cores, you got 10 of them just chilling, or however many, you've sort of done enough work to like do in parallel, then you could have them laying around and just send like, okay, now I want you to run this function, and now I want you to run this, and that one means go call that API and then process it. And I think you could get the difference between threading and subinterpreters a lot lower by having them kind of reused, basically.
Yep. Absolutely.
Yeah.
There's some of the key difference, I think, is mostly that when you have mutable data, whereas with threads you can share it, so threads can kind of talk to each other through the data that they share with each other. Whereas with subinterpreters, there are a lot of restrictions, and I expect we'll work on that to an extent. But it's also part of the programming model. And like Anthony was saying, if you really want to take advantage of parallelism, you need to think about it. You need to actually be careful about your data and how you're splitting up your work.
I think there's going to be design patterns that we come to know, or conventions we come to know. Like, let's suppose I need some calculation, and I'm going to use it in a for loop. You don't run the calculation if it's the same over and over every time through the loop. You run it and then you use the result, right? So in this, a similar thing here would be like, well, if you're going to process a bunch of data and the data comes from, say, a database, don't do the query and then hand it all the records. Just tell it, go get that data from the database. That way it's already serialized in the right process, and there's not this cross serialization to either pickling or whatever mechanism you come up with, right? But like, try to think about when you get the data, can you delay it until it's in the sub process or sub interpreter rather, and so on, right?
Yeah, definitely. One interesting thing is that PEP 734, I've included memory view as one of the types that's supported. So basically, you can take a memory view of any kind of object that implements the buffer protocol, so like NumPy arrays and stuff like that, and pass that memory view through to another interpreter, and you can use it, and it doesn't make a copy or anything. It actually uses the same underlying data that actually gets shared.
Oh, that's interesting.
Yeah, so and I think there's even more room for that with other types, but we're starting small. But the key thing there is that, like you're saying, I mean, with coming up with different models and patterns and libraries, I'm sure they'll come up as people feel out really what's the easiest way to take advantage of these features, and that's the sort of thing that will apply not just to general free-threaded like no-GIL, but also subinterpreters.
Definitely. It's going to be exciting. So I guess I want to move on and talk about working with this in Python and the stuff that you've done, Anthony. But maybe a quick comment from the audience is Jazzy asks, is this built on top of a queue, which is built on top of linked lists? Because I'm building this and this, my research led me to these data structures. I guess that's the communication cross interpreter communication.
Yeah, with subinterpreters, like in PEP 734, it's a queue implements the same interfaces as the queue from the queue module. But there's no reason why people couldn't implement whatever data structure they want for communicating between subinterpreters, and then that data structure is in charge of preserving thread safety and so forth.
Yep. Excellent. Yeah, it's not a standard queue. It's like a concurrent queue or something along those lines.
Yeah.
Yeah. All right. So all of this we've been talking about here is, we're looking at this cool interpreter pool executor stuff. That's in draft format, Anthony, for 3.13. And somehow I'm looking at this running Python parallel applications and subinterpreters that you wrote. What's going on here? How do you do this magic?
You need to know the secret password. So in Python,
right there,
in Python 3.12, the C API for creating subinterpreters was included, and a lot of the mechanism for creating subinterpreters was included. So there's also in CPython, there's a standard library, which I think everybody kind of knows. And then there are some like hidden modules, which are mostly used for testing. So not all of them get bundled, I think, in the distribution. I think a lot of the test modules get taken out. But there are some hidden modules you can use for testing, or because a lot of the test suite for CPython has to test C APIs, and nobody really wants to write unit tests in C. So they write the tests in Python, and then they kind of create these modules that basically just call the C functions. And so you can get the test coverage and do the testing from Python code. So I guess what was from PEP 6, I can't remember. I look at too many PEPs. 6. Eric will probably know. What is now PEP 734. But the Python interface to create subinterpreters, a version of that was included in 3.12. So you can import this module called _xx subinterpreters. And it's called _xx because it kind of indicates that it's experimental, and it's underscore because you probably shouldn't be using it.
It's not safe for work to me. I mean,
yeah,
I don't know.
But it provides a good way of people actually testing this stuff and seeing what happens if I import my C extension from a subinterpreter. So that's kind of some of what I've been doing, is looking at, okay, what can we try and do in parallel? And this blog post, I wanted to try a WSGI or an ASCII web app, and the typical pattern that you have at the moment, and I guess how a lot of people would be using parallel code but without really realizing it, is when you deploy a web app for Django Flask or Fast API, you can't have 1 GIL per web server, because if you've got 1 GIL per web server, you can only have 1 user per website, which is not great. So the way that most web servers implement this is that they have a pool of workers. Gunicorn does that by spawning Python processes and then using the multi-processing module. So it basically creates multiple Python processes all listening to the same socket. And then when a web request comes in, one of them takes that request. It also then inside that has a thread pool. So even basically the thread pool is better for concurrent code. So Gunicorn normally is used in a multi-worker, multi-thread model. That's how we kind of talk about it. So you'd have the number of workers that you have CPU cores, and then inside that you'd have multiple threads.
Right.
So kind of means you can handle more requests at a time. If you've got 8 cores, you can handle at least 8 requests at a time. However, because most web code can be concurrent on the back end, like you're making a database query or you're reading some stuff from a file like that, that doesn't necessarily need to hold the GIL. So you can run it concurrently, which is why you have multiple threads. So even if you've only got 8 CPU cores, you can actually handle 16 or 32 web requests at once, because some of them will be waiting for the database server to finish running its SQL query or the API that it called to actually reply. So what I wanted to do with this experiment was to look at the multi-worker, multi-thread model for web apps and say, okay, could the worker be a subinterpreter? And like, what difference would that make? So instead of using multi-processing for the workers, could I use subinterpreters for the workers? So even though the Python interface in 3.12 is experimental, they basically wanted to adapt Hypercorn, which is a web server for ASCII and WSGI apps in Python. Wanted to adapt Hypercorn and basically start Hypercorn workers from a subinterpreter pool, and then seeing if I can run Django, Flask, and Fast API in a subinterpreter. So a single Python process, but running across multiple cores and listening to web requests and basically running and serving web requests with multiple GILs. So that was the task.
In your article, you said you had started with a GUnicorn, and they just made too many assumptions about the multiprocess, the web workers being truly sub processes. But Hypercorn was a better fit, you said, from Phil.
Yeah, it was easier to implement this experiment in Hypercorn. It had like a single entry point, because when you start a subinterpreter, you need to import the modules that you want to use. You can't just say run this function over here. You can, but if that function relies on something else that you've imported, you need to import that from the new subinterpreter. So what I did with this experiment was basically start a subinterpreter that imports Hypercorn, listens to the sockets, and then is ready to serve web requests.
Interesting. Okay, and at a minimum, you got it working, right?
Yeah, it did a hello world. So we got that working. So I was pleased with that. And then kind of started doing some more testing of it. So, how many concurrent requests can I make at once? How does it handle that? What does my CPU core load look like? Is it distributing it well? And then kind of some of the questions are, how do you share data between the subinterpreters? So the minimum I had to do was each subinterpreter needs to know which WebSocket should I be listening to. So like which network socket, once I've started, what port is it running on? And is it running on multiple ports? And which one should I listen to? So yeah, that's the first thing I had to do.
Nice. Yeah, maybe just tell people real quick about just like what are the commands like at the Python level that you look at in order to like create an interpreter, run some code on it, and so on. What's this weird world look like?
Eric, do you want to cover that?
Yeah, there isn't a whole lot. I mean, if we talk about PEP 734, you have an interpreters module with a create function in it that returns you an interpreter object. And then once you have the interpreter object, you'll have it has a function called run, or a method. And the interpreter object also has a method called exec. I'm trying to remember what it was. Exec sync, because it's synchronous with the current thread. Mm-hmm. And whereas exec run will create a new thread for you and run things in there. So they're kind of different use cases, but it's basically the same thing. You have some code currently supports just you give it a string with all your code on it, like you load it from a file or something. Basically it's a script that's going to run in that subinterpreter. Alternately, you can give it a function, and as long as that function isn't a closure, doesn't have any arguments and stuff like that. So it's just like really basically a script, right? If you got something like that, you can also pass that through, and then it runs it, and that's just about it. If you want to get some results back, you're going to have to manually pass them back, kind of like you do with threads. But that's something people already understand pretty well.
Right. You create one of those channels, and
Yep.
then you just wait for it to exit and then read from the channel, something like that.
Yeah.
Yeah. And so there's a way to say things like just run. And there's also a way to say create an interpreter, and then you could use the interpreter to do things. And that lets you only pay the process like startup cost once, right?
Yeah. Yeah. And you can also, you can call that the run multiple times. And each time it kind of adds on to what ran before. So if you run some code that modifies things or imports some modules and that sort of thing, those will still be there the next time you run some code in that interpreter, which is nice because then if you got some startup stuff that you need to do one time, you can do that ahead of time right after you create the interpreter. But then in kind of your loop in your worker, then you run again and all that stuff is ready to go.
Oh, that's interesting. Because and I think about, say, my web apps, a lot of them talk to MongoDB and use Beanie, and you go to Beanie and you tell it to like create a connection or a MongoDB client pool, and it does all that stuff. And then you just ambiently talk to it, like go to that, kind of like Django or whatever, right? Go to that class and do a query on it. You could run that startup code like once potentially and have that pool just hanging around for subsequent work.
Mm-hmm.
Nice. All right. Let's see some more stuff. So, you said you got it working pretty well, Anthony, and you said one of the challenges was trying to get it to shut down, right?
Mm.
Yeah.
Yeah. So in Python, when you start a Python process, you can press Control-C to quit, which is a keyboard interrupt. That kind of sends the interrupt in that process. All of these web servers have got like a mechanism for cleanly shutting down, because you don't want to just, if you press Control-C, you don't want to just terminate the processes, because when you write an ASCII app in particular, you can have like events that you can do. So people who've done Fast API probably know the on event decorator that you can put and say, when my app starts up, create a database connection pool, and when it shuts down, then go and clean up all this stuff. So if the web servers decided to shut down for whatever reason, whether you've pressed Control-C or it just decided to close for whatever reason, it needs to tell all the workers to shut down cleanly. So signals, like the signals module, doesn't work between subinterpreters because it kind of it sits in the interpreter state, from what I understand. So what I did was basically use a channel so that the main worker, like the coordinator, when that had a shutdown request, it would send a message to all of the subinterpreters to say, okay, can you stop now? And then it would kick off a job, basically tell Hypercorn, in this case, to shut down cleanly, call any shutdown functions that you might have, and then log a message to say that it's shutting down as well. Because the other thing is with web servers is, if it just terminated immediately, and then you looked at your logs and you were like, okay, why did the website suddenly stop working? And there was no log entries, and it just went from I'm handling requests to just, absolute silence. That also wouldn't be very helpful. So it needs to write log messages. It needs to call like shutdown functions and stuff. So what I did was, and this is, I guess, where it's kind of a bit of a turtles all the way down, but inside the subinterpreter, I start another thread. Because if you have a poller which listens to a signal on a channel, that's a blocking operation. So, at the bottom of my subinterpreter code, I've got, okay, run Hypercorn. So it's going to run, it's going to listen to the socket, serve web requests. But I need to also be able to run concurrently in the subinterpreter a loop which listens to the communication channel and sees if a if a shutdown request has been sent. So this is kind of maybe an implementation detail of how interpreters work in Python, but interpreters have threads as well. So you can start threads inside interpreters. So similar to what I said with GUnicorn and Hypercorn, how you got multi-worker, multi-thread, like each worker has its own threads. In Python, interpreters have the threads. So you can start a subinterpreter, and then inside that subinterpreter, you can also start multiple threads. And you can do coroutines and all that kind of stuff as well. So basically what I did is to start a subinterpreter, which also starts a thread, and that thread listens to the communication channel and then waits for a shutdown request.
Right. Tells Hypercorn, all right, you're done. We're out of here. Yeah. Okay. Interesting. Here's a interesting question from the audience from Chris. Well, it says, we talked about the global kind of startup, like if you run that once, it'll already be set. And, does that make code somewhat non-deterministic in the subinterpreter? I mean, if you explicitly work with it, no. But if you're doing the pool, like which one do you get? Is it initialized or not? Eric, do you have an idea of like a startup function that runs in the interpreter pool executor type thing, or is it just they get doled out and they run what they run?
With concurrent.futures, it's already kind of a pattern. You have an initialize function that you can call that'll do the right thing, and then you have your work that actually your task that the worker's actually running. So with the I don't know. I wouldn't say it's non-deterministic unless you have no control over it. I mean, it's if you want to make sure that state progresses in an expected way, then you're going to run your own subinterpreters, right? But if you have no control over the subinterpreters, you're just like handing off to some library that's using subinterpreters. I would think it'd be somewhat not quite so important about whether it's deterministic or not. I mean, each time it runs, there are a variety of things. The whole thing could be kind of reset, or you could make sure that anything that runs in any part of your code that runs is careful to keep its state self-contained, and therefore you preserve deterministic behavior that way.
One of the things I do a lot is I'll write code that'll say, if this is already initialized, don't do it again. So I talked about like the database connection thing. If somebody were to call it twice, it'll say, well, looks like the connection's already not none, so we're good, right? You could just always run the startup code with one of these like short circuit things that says, hey, it looks like on this interpreter, this is already done, we're good. But that would probably handle a good chunk of it right there.
Yeah.
But we're back to this thing that Anthony said, right? Like we're going to learn some new programming patterns potentially. Yeah, quite interesting. So we talked at the beginning about how subinterpreters have their own memory and their own module loads and all those kinds of things. And that might be potentially interesting for isolation. Also kind of tying back to Chris's comment here, this isolation is pretty interesting for testing, right, Anthony? Like PyTest. So another thing you've been up to is working with trying to run PyTest sessions in subinterpreters. Tell people about that.
Yeah. So I started off with a web worker. One of the things I hit with a web worker was that I couldn't start Django applications, and realized the reason was the date time module. So the Python standard library, some of the modules are implemented in Python, some of them are implemented in C, some of them are a combination of both. So some modules you import in the standard library have like a C part that's been implemented in C for performance reasons typically, or because it needs some special operating system API that you can't access from Python. And then the front end is Python. so there is a list basically of standard library modules that are written in C that have some sort of global state. And then the core developers have been going down that list and fixing them up so that they can be imported from a subinterpreter, or just marking them as not compatible with subinterpreters. One such example was the readline module that Eric and I were kind of working on last week and the week before. Readline is used for, I guess, listening to like user input. So if you run the input built-in, like readline is one of the utilities it uses to listen to keyboard input. If you start, let's say you started 5 subinterpreters at the same time and all of them did a readline listen for input, like what would you expect the behavior to be? Which when you type in the keyboard,
yeah, exactly.
Yeah, where would you expect the letters to come out? So it kind of poses an interesting question. So readline is not compatible with subinterpreters, but we discovered like it was actually sharing a global state. So when it initialized, it would install like a callback. And what that meant was that even though it said it's not compatible, if you started multiple into subinterpreters that imported readline, it would crash Python itself. The datetime module is another one that's that needs fixing. It installs a bunch of global state. So yeah, datetime was another one. So what I wanted to do was to try and test some other C extensions that I had, and just basically write a PyTest extension, or a PyTest plugin, I guess, which you've got an existing PyTest suite, but you want to run all of that in a subinterpreter. And the goal of this is really that you're developing a C extension, you've written a test suite already for PyTest, and you want to run that inside a subinterpreter. So I'm looking at this from a couple of different angles, but I want to really try and use subinterpreters in other ways, import some C extensions that have never even considered the idea of subinterpreters and just see how they respond to it. Like readline was a good example. Like I think it was this won't work, but the fact that it crashed is bad.
How is it going to crash, right? Like what's happening there?
Yeah, so it should have kind of just said this is not compatible, and that's kind of uncovered and this is all super experimental as well. So like this is not you've had to import the _XX module to even try this. So yeah, there's readline, datetime was another one. And so I put this sort of PyTest extension together so that I could run some existing test suites inside subinterpreters. And then the next thing that I looked at doing was CPython has a huge test suite. So basically how all of Python itself is tested, the parser, the compiler, the evaluation loop, all of the standard library modules have got pretty good test coverage. So like when you compile Python from source or you make changes on GitHub, like it runs the test suite to make sure that your changes didn't break anything. Now the next thing I kind of wanted to look at was, okay, can we, to try and kind of get ahead of the curve really on subinterpreter adoption. So in 3.13, when PEP 7.3.4 lands, can we try and test all of the standard library inside a subinterpreter and see if it has any other weird behaviors? And this test will probably apply to free threading as well, to be honest, because I think anything that you're doing like this, you're importing these C extensions, which always assume that there was a big GIL in place. If you take away that assumption, then you get these strange behaviors. So yeah, the next thing I've been working on is basically running the CPython test suite inside subinterpreters and then seeing what kind of weird behaviors pop up.
I think it's a great idea because obviously CPython is going to need to run code in a subinterpreter, run our code, right? So it, at a minimum, the framework, the interpreter, all the runtime bits, that should hang together, right?
Yeah, there are some modules that it doesn't make sense to run in subinterpreters. Readline was an example.
Some TK enter maybe.
Yeah, possibly.
Maybe not, actually. I
So
don't know.
yeah,
If you think about like if you got when you're doing GUI programming, right, you're going to have a kind of your core stuff running the main thread, right, and then you hand off. You may have subthreads doing some other work, but the core of the application, think of it as running in the main thread. I
Yeah,
think of
absolutely.
applications in that way, and there's certain things that you do in Python standard library modules that really only make sense with that main thread. So supporting those in subinterpreters isn't quite as meaningful.
Yeah, I can't remember all the details, so I feel like there's some parts of Windows itself, some UI frameworks there that required that you access them on the main program thread, not
Mhm.
on some background thread as well, because it'd freak things out. So
Yeah,
it seems like
the
not
same.
unreasonable.
Yeah, same is true. Like the signal module, if I remember right, add exit, a few others.
Excellent. All right. Well, I guess we're getting short on time. Let's wrap it up with this. So the big thing to keep an eye on really here is PEP 734, because that's when this would land. You're no longer with the _ XX subinterpreter. You're just working with the interpreters submodule.
Yeah, 313.
So, yeah. So right now it's in draft. Like, what's it looking like? If it'll be in 313, it'll be in 313 alpha something, some beta something. Like, when is this going to start looking like a thing that is ready for people to play with?
So this PEP, I went through and did a massive cleanup of PEP 554, which is why I made a new PEP for it, and simplified a lot of things, clarified a lot of points, had lots of good feedback from people, and ended up with what I think is a good API, but it was a little different in some ways. So I've had the implementation for PEP 554 mostly done and ready to go for years. And so it was it's been a matter of, now that I have this updated PEP up, going back to the implementation, tweaking it to match, and then making sure everything still feels right. Try and use it in a few cases, and if everything looks good, then go ahead and I'll start a discussion on that. I'm hoping within the next week or two to start up a round of discussion about this PEP, and hopefully we won't have a whole lot of back and forth, so I can get this over to the steering councils in the near future.
Well, the hard work has been done already. All right.
Yeah.
The C layer is there and it's accepted and it's in there. Now it's just a matter of what's the right way to look at it from Python, right?
And one thing to keep in mind is that I'm planning on backporting the module to Python 3.12, just so that we have a per interpreter GIL in 3.12. So it'd be nice if people could really take advantage of it. So
I see. So for that one, we'd have to pip install it, or would it be added as?
Yeah, pip install.
Okay.
I probably won't support before 3.12. I mean, subinterpreters have been around for decades, but only through the C API. But that said, I doubt I'll backport this module past 3.12. So just 3.12 and up.
And that's more than I expected anyway, so that's pretty cool. All right, final thoughts, you guys. What do you want to tell people about this stuff?
Personally, I'm excited for where everything's going. It's taken a while, but I think we're getting to a good place. It's interesting with all the discussion about no GIL. It's easy to think, oh, then why do we need subinterpreters? Or if we have subinterpreters, why do we need no GIL? But they're kind of different needs that they're meeting. The most interesting thing for me is that what's good for no GIL is good for subinterpreters and vice versa. That no GIL probably really wouldn't be possible without a lot of the work that we've done to make a per interpreter GIL possible. So I think that's one of the neat things. The future's looking bright for Python multicore. And I'm excited to see where people go with all of these things that we're adding.
Anthony, when's the subinterpreters programming design patterns book coming out?
Yeah, my thoughts are I will. Oh, there's a subinterpreters are mentioned in my book actually when it was like Python 3.9, I think. Because it was possible then, but it's changed quite a lot since. I guess they kind of some thoughts to leave people with. I think if you're a maintainer of a Python package or a C extension module in a Python package, there's going to be a lot more exotic scenarios for you to test coming in the next year or so. And some of those uncover things that you might have done or just kind of relied on the GIL with global state, where that's not really desirable anymore, and you're going to get bugs down the line. So I think with any of that stuff as a package maintainer, you want to test as many scenarios as you can so that you can catch bugs and fix them before your users find them. So if you are a package maintainer, there's definitely some things that you can start to look at now to test that's available in 3.13 Alpha 2 is at least probably the one I'd try, to be honest. And if you're a developer, not necessarily a maintainer, then I think this is a good time to start reading up on like parallel programming and how you need to design parallel programs. And those kind of concepts are the same across all languages, and Python would be no different. We just have different mechanisms for starting parallel work and joining it back together. But if you're interested in this and you want to run more code in parallel, there's definitely some stuff to read and some stuff to learn about in terms of signals, pipes, queues, sharing data, how you have locks and where you should put them, how deadlocks can occur, things like that. So all of that stuff is the same in Python as anywhere else. We just have different mechanisms for doing it.
All right. Well, people have some research work. And I guess a really, really quick final question, Eric, and then we'll wrap this up. Following up on what Anthony said, like test your stuff, make sure it works in a subinterpreter. If for some reason you're like, my code will not work in a subinterpreter and I'm not ready yet, is there a way to determine that your code is being run in a subinterpreter rather than regularly from your Python code?
Yeah, if you have an extension module that supports subinterpreters, then you will have updated your module to use what's called multi-phase init. And that's something that shouldn't be too hard to look up. I think I talk about it in the PEP. If you implement multi-phase init, then you've already done most of the work to support a subinterpreter. If you haven't, then your module can't be imported in a subinterpreter. It'll actually fail with an import error if you try and import it in a subinterpreter, or at least a subinterpreter that has its own GIL. There are ways to create subinterpreters that still share a GIL and that sort of thing. But you just won't be able to import it at all. So like the readline module can't be imported in subinterpreters. The issue that Anthony ran into is kind of a subtle side effect of the check that we're doing. So, but really it boils down to, if you don't implement multi-phase init, then you won't be able to import the module. You'll just get an import error. So that's, it makes it kind of straightforward.
Yeah, sounds good. More opt-in than opt-out.
Yep.
Right on. All right, guys. Thank you both for coming back on the show, and awesome work. This is looking close to the finish line and exciting.
Thanks, Michael.
Yep. See y'all.